This demonstration shows why security is necessary by showing a fictionalized scenario between two people. One is a legitimate user of a Hadoop cluster, owned and managed by a fictional telecommunications company named Loudacre Mobile. The other is someone who wants to attack the cluster and get access to the valuable data stored there. We'll begin by looking at the attacker's session, which starts with her cracking a weak password associated with an account that is sometimes found on Unix systems.
Last night, I ran a stealthy port scan against some IP addresses that a friend told me are managed by that big phone company, Loudacre Mobile. It took a while, but by the time I was done, I had a few IP addresses that are listening on port 22. That's the port for the secure shell service. Well, the service itself might be secure, but we'll just see how secure the passwords they use are. If they have a good intrusion detection system set up, I might get noticed by a watchful system administrator if I try a brute force attack that attempts thousands of username and password combinations. That's why I'm going to concentrate on cracking the password for just the support account. That's not a standard account on most Unix systems, but it is a fairly common one. In my experience, it's usually one set up by a lazy system administrator for use by multiple people, because the administrator didn't want to bother setting up a new group and individual accounts for each member. And if the system administrator was too lazy to do that the right way, and there is a shared support account, it probably means that the administrator does not have an intrusion detection system and probably doesn't bother to enforce a good password policy either. In other words, if this account exists, then it should be pretty easy to crack, and there's probably not much risk of getting caught. I'm going to try running my password cracker against one of those IP addresses to see if it can guess the support account password. Great! I was able to find the password for the support account, and, just as I guessed, it's a pretty weak one. I really wish I had root access on that machine, but since the system administrator has done a poor job of securing the system, it shouldn't be hard to get it. Now that I know the username and password, I'll use it to log into that server, then poke around and see what I can find. The first thing I do when I get into a new system is see what looks interesting. That backup directory looks pretty interesting. I'm not sure if it has files that have been backed up or scripts that are used for making backups, but there's one way to find out. I'll log into that directory, and then have a look at the files there. Ooh, see that bright red there for the run backup file? That's bad for them, but good for me. I've seen this before, and I think I know what they've done. If I'm right, it means I'm going to have root access in just a couple minutes. And once I do, then whatever data is on this machine is mine. Okay, let me explain. Normally, when you execute something on a Unix system, whether it's compiled binary or just a shell script, it runs under your own account. In other words, it can't access any file that you can't access on your own. That's a problem for certain programs, like the ones used to back up the system, because they need access to every file regardless of who owns it. There are many ways of solving this problem, but one way, one of the worst actually, is to enable what's known as the setuid bit in the permissions of that executable. Doing that tells the operating system that instead of running as the person who launched it, it should run as the person who owns the file. For this file, that owner happens to be root. That means that if I can insert something into the execution, that's going to run as root too. Since backup scripts might change from time to time, they're often implemented as shell scripts, which are simple to write and easy to modify. Because the setuid bit is so dangerous, and so often the source of security problems, modern Unix systems don't allow you to set it on shell scripts. I think the system administrator just wrote a little program in C that does nothing more than run that shell script, compiled that C program into an executable, and enabled the setuid bit on it. That workaround effectively allows the shell script to run as root no matter who launches it, so anyone can run backups. Unfortunately for the system administrator, it also means that anyone who can modify the shell script has the ability to run something as root. So if that something I launch is the shell, then I'll have root access whenever I need it. I'll just try running the script as it is before making my modifications. That seems to be what I thought, so let's see if I can modify that shell script and get root access. I'll add a line to launch a new shell and then save the file. Since that script runs as root, the shell it spawns as a result of my change should also run as root. Let's see if it works. First, I'll execute the Who Am I command to show that I'm still logged in as support, which is the account I cracked to gain access to this system. Next, I'll run the modified script that I hope will give me root access to this system. Although the shell prompt should be a clue that I now have root access, I'll run the Who Am I command again to prove that it worked. Excellent! Now that I've gained access, I'll have a look around and see if there's any interesting data on this system. Come to think of it, I don't even know what this system does yet. Maybe I can figure that out, too.
Unfortunately for Loudacre Mobile, the machine that was just compromised happens to be a worker node in a Hadoop cluster, which never should have been available across the internet via Secure Shell in the first place. In addition to a lack of proper perimeter security, the poor host security allowed a weak password that offered easy access to the attacker, and the insecure homegrown backup script allowed this attacker to then gain total access to this machine. A poor security implementation by a badly trained system administrator has caused the first several lines of defense to fail. This cluster was configured with all the default settings, which means that it isn't using Kerberos for authentication, isn't using TLS to protect data in motion, and isn't using encryption to protect data at rest. Because the attacker now has root access, she'll be able to see data stored in HDFS by looking directly at the block files on the local file system of this machine. That includes confidential data that Loudacre has a duty, and very likely also a legal obligation, to protect.
Because I'm looking for data, I'll start by looking at which directories contain the most data. Let's see what the top 5 are. I wonder what DFS is. Well, because credit card numbers follow a pretty predictable pattern, I'll run a recursive grep command to see if anything in that directory matches. Maybe I've stumbled onto some financial information. It took almost a minute for that command to finish, but it was time well spent. These look like credit card numbers, complete with the names, addresses, and other contact information I'd need to use them.
We've just seen how the attacker was able to view customer credit card information because the cluster fails to protect data at rest. Since Loudacre's system administrator has also failed to protect data in motion, it's sent across the network in clear text, visible to our attacker and potentially anyone else with access to the same network, as you'll see in a moment.
Now that I've searched what's on the disk, let's see what's happening on the network interface. I doubt the tools I need for this are already on the machine, but they're easy enough to install if the system administrator hasn't locked things down too much. I'll install one of my favorite network diagnostic tools so that I can see the information being transmitted to and from this machine. Now that I've got the program I need, I'm going to use it to capture the packets flowing through the primary Ethernet interface. Once I save it to a file, I can take all the time I need to inspect it and look for patterns that might relate to confidential things, like credit card numbers, email addresses, or other valuable information.
It just so happens that while our attacker is capturing network traffic, a data analyst at Loudacre named Jan Smith is doing some Hive queries to get data for a marketing campaign.
Okay, I should have captured enough traffic to find something interesting by now. I wonder if there are any email addresses here. Yep, looks like I've found some. Well, that's enough for now. Now for the hard part, deciding whether I should use these credit card numbers to buy some new equipment for myself or get paid by selling this data to others.
You've just had a brief look at how an attacker compromised a system to get access to confidential data that should have been protected. She first gained access because the system was unnecessarily available for remote logins across the internet, and because it was protected with a weak password. She then gained root access by exploiting a security hole in a homegrown backup script. The lax perimeter and host security on this system made it easy for the attacker to get in, which gave her the opportunity to read confidential data on disk and on the network. Please pause for a moment and consider what types of defenses you might have implemented as system administrator to help prevent this breach. Here are a few things that could have helped. You could limit remote access to what's truly needed. There's very little reason for a Hadoop cluster in Loudacre's data center to be available through Secure Shell to anyone on the internet. You could enforce better password standards so that a weak and common password like let me in wouldn't be allowed in the first place. You could run system audits and review logs on a regular basis to identify potential security problems, such as set UID binaries or unexpected package installations, and then promptly address the problems you find. You could use an intrusion detection system so you'll be notified of an attack in progress and be able to respond quickly. This would likely have alerted you to the port scan that preceded the attack, as well as the attempts to crack the password for the support account. Finally, you could use encryption to protect data in motion and at rest.